So we can start now. This is our day 4 lecture, aircraft propulsion. In last lecture we have seen the formula of enthalpy. It looks like capital H is equal to U plus PV, and we are going to discuss here specific enthalpy. So we have seen properties, how to convert them into a specific property. We will divide our total property by mass. So this will become your specific property. So this became your specific enthalpy. That is nothing but your total internal energy and PV when you divide by mass. Okay, so if you bother about the unit, so here, here and here, everywhere your unit is joule, that is SI unit, but in this case your unit is joule per kg. So this is a very basic difference between specific enthalpy and total enthalpy. Everyone please mute. Okay, now we are going to discuss here ideal gas law. So before discussion of ideal gas law, we should understand what is ideal gas. So ideal gas, and why to bother about ideal gas, why there is need to study ideal gas, because we have to face some assumptions. For example, in our jet engine, from here we supply air. So air mass flow rate we say as m dot A, and from here we supply fuel. So fuel mass flow rate we say m dot F. But when both of them they come closer, I mean when they both react with each other, they make m dot gas. So here m dot gas is nothing but m dot A plus m dot F. But in many of the GATE questions and assignment questions and test series question, there is need to assume that this m dot F value, even though fuel is present for the burning process, but we consider that negligible. So in that case we consider m dot G roughly equal to m dot A. Okay, but effect of the fuel is definitely there, burning part is there, but mass wise we consider this. Okay, so you see here, if there is need we can go through assumption. In same way we have assumption about gases. So what kind of assumptions we are applying on gases? So that is actually coming from ideal gas concept. So first we will understand what is ideal gas, and then we will understand